This video is about rotation, and rotation is transformations that turn the object. And this turning can occur in two different directions. We can have clockwise rotation, which takes place in the same direction as the hands of a clock turn. But we can also have anti-clockwise rotation, which simply takes place in the opposite direction. And sometimes this anti-clockwise rotation can be referred to as counterclockwise rotation. So anti-clockwise and counterclockwise just mean the same thing. As well as referring to the direction in which rotation takes place, we also encounter descriptions of the angles of rotation. And the angles that we most commonly encounter are a 90-degree rotation, which is a quarter turn, a 180-degree rotation, or a half a turn, and 360-degree rotation, or a full turn. So let's have a look at an example. Here I have my object, which is a triangle. My question is to find the image under 90-degree clockwise rotation. Remember that clockwise means that we're turning in the same direction as the hands of a clock, just like the arrow does here. So if my object is in this position and I want to find the image, I'm going to make a quarter turn. And this new triangle is my image. Just notice that when I look at my object, and look at the left-hand side here in particular, I'm just focusing on that for a moment, I've highlighted it here, and look at the corresponding side in the image, which I've also highlighted, I can see that these two lines are at right angles to one another. They're perpendicular. And I'm not surprised by that because I created a 90-degree clockwise rotation. And so the 90 degrees is reflected in the angle at which these lines would meet. Here's a second example. Again, I've got the same object. I want to find its image, this time under 180-degree clockwise rotation. Remember that clockwise rotation, I'm going in the same direction as the hands of the clock. So if my object begins in this position, then to get its image under 180-degree clockwise rotation, I'm going to have to make it do a half a turn, half of a full turn. And this triangle is my image. You might notice in the case of a 180-degree rotation that my image, when I compare it to my object, is upside down and back to front. This was also the result of a different type of transformation. Can you remember what it was? Central symmetry in a point had the same result. So rotation under 180 degrees can have the same outcomes as central symmetry through a point. And one last example using this triangle. So I have my object on the left and I want to find its image under 360-degree clockwise rotation. And again, I'm going in the same direction as the hands of a clock. So my object begins here on the left. And when I turn it through 360, I'm basically taking 4 90-degree turns. So there's 190. And then I turn through another 90. So I've turned through 180 now. And then I turn through another 90. So I'm at a 270-degree rotation. And then I turn through another 90. And here's my image in this case. And you'll notice that the image looks exactly like the original object. It's made a full turn, so it's facing back in the same direction again. So here's one further example now, just to show you the situation with anti-clockwise rotation. So I have my object. I want to find its image using 90-degree anti-clockwise rotation. So this time I'm going in the opposite direction to the direction that the hands of a clock would travel. And so if my object is initially located here, and I want to rotate it through 90 degrees, anti-clockwise, I'm going to end up with an image like this. And here's one further example with this rectangle. Again, I've got the object. I want to find its image this time using 180-degree anti-clockwise rotation. So again, that's the opposite way to the way that the hands of the clock travel. And so if my object begins looking like this, I'm going to take it through a half turn, so 90 and a further 90, and my image is going to look like this. And just notice here that with this particular shape, the object and the image, aside from being in different places, they look exactly the same. I wonder, is there any other transformation that would get me from an object like this to an image like this? So think back through the different types that we've had: translation, axial symmetry, central symmetry, and now rotation. And let's just think, how could I get from this object to this image? Well, we've already spoken in this video about the idea of 180-degree rotation having the same effect as central symmetry. And while the object and the image look identical, we can also see that the image is actually the object upside down and back to front. Hence the link to central symmetry, even though in this case, upside down and back to front looks the exact same as the original. We can also see how the object could be reflected through an axis to make this image. So in this case, axial symmetry could have the same effect to get from this object to this image. And in fact, in this particular situation, I could also have simply taken my object and pushed it across my page until it ended up in this position. And that type of transformation is called a translation. So it's interesting to note that different types of transformations can yield the same resulting image at the end. There's more than one possible transformation that will take you from this object to this image.